So something we mentioned when we were doing Pascal's triangle was anything to the 0 power is 1. So any number n, if n, you have n to the 0 power, it's going to equal 1. Meaning any number to the 0 power equals 1. I think then would make more sense than if in your notes. Then n to the 0 equals 1. For any number n, then n to the 0 equals 1. So that means you could have just a regular old number, 4 to the 0 power. That's going to equal 1. You could have a variable, x to the 0 power. That could equal 1. You could have a whole quantity, 3y to the 4th to the 0 power, and that's going to equal 1. Anything to the 0 power equals 1. Well, like I said before, we're going to talk about that tomorrow. Why is that true? Why does that happen? But for right now, we'll just take it as a general rule. Any number to the 0 power is going to equal 1. Next, we can talk about if we are multiplying like bases with exponents. So maybe, for example, m to the a times m to the b. The rule is that you add your exponents. So m to the a plus b. So some examples could be x to the 3rd times x to the 5th. Just add your exponents, you get x to the 8th. Say we have ab squared times a to the 6th. Now you can only multiply your like bases, so we can only multiply the a and the a. Make sure you remember that even though this is only a, that is to the 1st power. We don't write to the 1st power, but you still need to include it. So that's a to the 1st power times a to the 6th power. That's going to give you a to the 7th, and then b squared. Yeah, Ryan?
Should you put the higher exponent first?
You should go alphabetically with your variables, and then if you're thinking kind of standard form, putting the highest exponent first. You would if it was standard form, but since I'm using variables, I put alphabetically A before B. If you wrote it the other way, it wouldn't be wrong. The next thing we want to talk about would be dividing like bases. So we'll just use a general case of m to the a over m to the b is going to equal m to the a minus b. So when you're dividing like bases, you subtract the exponents. So something like x to the 7th over x to the 3rd. 7 minus 3 is x to the 4th. Maybe we would have r to the 5th s over r to the 2nd s. There you're going to subtract r, 5 minus 2, giving you r to the 3rd. 1 minus 1 would be s to the 0, and s to the 0 is just 1. So whenever you have the exact same variable and the exact same power being divided, it just equals 1. So your answer would just be r to the 3rd there. Now kind of a continuation of dividing your like bases and going into our negative exponents. What if we had something like this? X to the 3rd over x to the 5th. Steve?
X to the negative 2nd.
Exactly. If I follow my division rule and I subtract 3 minus 2, that's what I would get. Which then leads us into our negative exponent rule. In general, you cannot have negative exponents. So if you have a to, or we'll use m to the negative a equals 1 over m to the a. If I had 1 over m to the negative a, that would equal m to the a over 1. So what general conclusion could you make about negative exponents? How do you make a negative exponent positive? By moving it across the fraction bar. If I move an exponent across the fraction bar, the exponent becomes positive. So I would write yourself a note, move across fraction bar to make positive. What if you don't have a fraction bar? Well, then you just create one. For example, in this division problem we did at the top, x to the negative 2, well, we can't have a negative exponent, so we have to move it across the fraction bar. There isn't one. Steve?
It would be 1 over x squared.
Exactly, because this is just like being over 1. Remember, even though it's not written, you can make anything into a fraction form by just putting it over 1. So then, just like Steve said, we leave the 1 in the numerator, we switch the x squared to the denominator. Your base must move with the exponent. You don't want to do something like x over 2 and just move the exponent. The base has to go with the exponent. Tulsi.
Let's say you had a negative up there, like x to the negative 3. Would you put it down first, or would you subtract negative 3 minus 5?
Okay, let's do that. So Tulsi was saying, what if we had x to the negative 3 over x to the 5th? Okay. What you would want to do first is to get rid of the negative exponent first. So first, what I would do is make this 1 over x to the 3rd, x to the 5th. And then use my multiplying like bases rule to make that 1 over x to the 8th. Technically, if you used your subtraction rule, if you did negative 3 minus 5, you would still get x to the negative 8th, and then you could switch it over. I think the first way that I did it is easier because then you're not subtracting negatives as much, but it's up to you. It's going to be personal preference for you. So whenever I am just dividing, thinking back to just division, and again, maybe I would have b to the 4th over b to the 8th. that would be b to the negative fourth, right? But what I do is I know that my exponent is going to stay in the denominator here, and it's going to be b to the fourth. So kind of a shortcut that I take is I know that if I'm dividing like bases, I'm going to have to subtract. And my exponent is always going to end up positive. I just look at where is the higher exponent to know where my base ends up, in the numerator or the denominator. So in short, I'm just kind of skipping this in-between step of saying this is b to the negative fourth. It doesn't matter which way you do it. If you like writing out b to the negative fourth and then moving it, that's fine. What I do is I just recognize all right, my higher exponent powers are in the denominator. That means I know that when I subtract, my exponents are going to be in the denominator. My bases and my exponents are going to end up in the denominator. So my x's, I would just do 8 minus 3, knowing that's going to be x to the fifth in the denominator. 7 minus 6 is just going to give me y in the denominator. Since there's nothing left in the numerator, you just put 1. But make sure there's a 1 there, because if there's not a 1, there's not a numerator. So out of curiosity, are you guys more likely to say x to the third over x to the fifth? Who is more likely to do this and then switch it over? Who likes that way better? Okay. And then would the rest of you say you would just rather take this and switch it right to 1 over x squared? Who would rather do it this way? Okay. Like I said, personal preference, whatever you want to do, you're still going to come up with the same answer. Okay, so far we have done adding exponents when we're multiplying like bases, subtracting exponents when we're dividing like bases, no negative exponents. To change a negative exponent to a positive, you have to move it with its base across the fraction bar. Oh, and anything to the 0 power equals 1. Something else we want to talk about is whenever you are taking a power to a power. Or an exponent to a power. So that would be something like a general case a to the m to the b power. The rule there is you multiply the exponents. So this would be a to the m times b. No, m to the a times b. So if I have x to the second power to the fourth power, multiply the exponents, that's x to the eighth. Maybe you would have 2y to the third power to the third power. Everything gets taken to that power. 2 to the third is 8. Y to the third to the third is y to the ninth. Power to a power, multiply the exponents. And that one kind of takes us to our next example about whenever you have anything in a quantity. If you have something in parentheses and you're taking it to a power, for example, a to the second, b to the fourth, and you're taking that all to the fifth power, then everything gets taken to that power. It's like saying a to the second to the fifth power, b to the fourth to the fifth power. Everything gets taken to the power. Power to a power, you multiply a to the 10th, b to the 20th. So let's just reiterate, if we have a quantity to a power, so maybe mn to the a power, everything in that quantity gets taken to the power. And that's the same for division as well. If you would have m over n to the a power, both the numerator and the denominator get taken to the power. Another, similar to the first one we did, 3xy to the second to the third power. That means everything here gets taken to the third power. If it's helpful, go ahead and write everything out to the third power like I did there in black. 3 to the third is 27. That is x to the first. So 1 times 3 gives you x to the third. And then y to the second to the third is y to the sixth. If I had a division problem, 2x to the fourth over y squared to the fourth. Everything gets taken to that power. And remember, everything in the numerator gets taken to that power. So that is 2 to the fourth power, x to the fourth to the fourth, and y squared to the fourth. Everything gets taken to that power. Giving you 16, x to the 16th over y to the 8th. Sometimes you may have a situation, and I think there were a few in the homework, where you had a quantity taken to a negative power. So if I would have something such as x squared y to the negative 3, all to the negative second power, what I believe the easiest thing to do would be to take that all to the second power first. So that means I'm going to have x squared to the negative second power and y to the negative third to the negative second power. What happens from there is you get x to the negative fourth, y to the sixth. And at that point, what should I do? Use the rules we were talking about earlier, because you're not allowed to have a negative exponent. If I don't want a negative 4 as an exponent, I'm going to leave y to the 6th in the numerator. That's a positive exponent. It doesn't need any changes. But now I'm going to take x to the 4th to the denominator. To make a negative exponent into a positive, you move it across the fraction bar. And that also works with numbers. Maybe I would have something like 2 over y to the 3rd to the negative 2nd power. That means everything gets taken to the negative 2nd. To make the negative exponents positive, move them across the fraction bar. So y to the 6 comes to the numerator. And then 2 to the negative 2 just goes to the denominator, to 2 squared, 2 to the positive 2 power, giving us y to the 6th over 4. Is there anything else from the homework that you did that you have a specific question on? Any specific ones from the homework? Okay, what I will do for you guys, I don't have a homework sheet for you right now because I didn't plan on doing this, but what I will do is I'll make up a homework worksheet and I'm going to post it on the wiki space. If you feel like you know your exponent rules and you don't need any more practice, then you don't need to do it. This is completely for those of you who feel like I need to catch up on my exponent rules because we will be using them. Your life will be easier if you know them. So I'm going to make a worksheet. I'll post it on the wiki space. So that is your homework tonight if you feel like you need extra practice.